Up until now, we have looked at how to find the solutions to an equation. That is, how to find values of our variable that make both sides of the equation true. What if we want to have one side be larger than the other? This is no longer an equation, this is called an inequality. As an example, 3 is less than 4. We define an inequality as a statement that one value is larger or smaller than another. Just like with equations, inequalities are statements, so they can either be true or false. In example 1, we have a true statement. That is, our inequality is true. What about the example, -2 is less than 4? Again, this inequality is true because -2 is less than 4. As for the example 7 is less than 4, this inequality is false. Just like with equations, inequalities get more interesting when we include a variable. With a variable, the inequality is sometimes true and sometimes false, depending on the value of the variable. In our fourth example, let's look at an inequality that involves a variable. Like the example, x is less than 4. Since this statement is only sometimes true, we want to know what values of x make it true. We define a solution to an inequality as a value of the variable that makes the inequality true. We saw in the first three examples that 3 and -2 are solutions to x less than 4, but that x equals 7 is not a solution. What other numbers will be solutions to x is less than 4? To visualize this, let's use our number line and consider all values that x could be. So far, we know that -2 is a solution as well as 3, both marked in green. We also know that 7 is not a solution, marked in red. We can also see that the numbers 2, 1, 0, -1, a half, 3.5 are all less than 4, so they are all solutions. And every number between these numbers are also solutions. Going further, all the values of x between 3.5 and 4 are solutions also, and all the numbers above 4 are not solutions, shown in red. So we looked at every value x could be except 4 itself. Is 4 a solution? Since x equals 4 and x is not less than 4, x equals 4 is not a solution to the inequality x is less than 4. Notice on the number line we use an open circle at 4. This means that we want all values up to 4 but not including 4. So we found that the inequality x less than 4 has infinitely many solutions, and we represented these solutions graphically with a number line. While this is a great visual representation of our solutions, we may not want to draw a number line every time we want to talk about solutions to an inequality. Additionally, this would be very difficult to submit answers on a computer for our online course. We have another way to represent these solutions, which are all the numbers from 4 down to -infinity. Or in other words, every number from -infinity up to 4. Our way of representing these is what's called interval notation. This says we want all the values from -infinity, our smaller number, up until 4, our larger number. It's worth noting two things. First, the round brackets mean x equals 4 and -infinity are not solutions. And also, WebWork will be looking for solutions to be in interval notation. Let's look at another example similar to our first one. We want to find all the values of x that are less than or equal to 4. The notation here means that we want all values of x that are either less than or equal to 4. In example 4, the only values that were solutions were the values of x strictly less than 4. For our new inequality, we will have all the solutions we had in example 4, because they were all less than 4, and additionally, we have the solution x equals 4. This is how we graphically represent it on the number line. The major difference is that we use a solid point at 4 to say that we want to include it, instead of our open point. In interval notation, we would write this as negative infinity up to 4. The difference here is that we use a square bracket at 4 to include it, instead of a round bracket.